Hello everyone, my name is Bradley Sward, and this video today is my solution to day 4 of the Advent of Code 2023 competition. The problem is called Scratchcards. I'm always using Python, at least nowadays I'm using Python for my programming language. So let's take a look at the problem. And so the problem is basically lottery or bingo or however you want to think about it. And so in this case here, you're looking at each individual card. To the left of the pipe are all the individual winning numbers for the game, whatever. And these are my numbers. And so in this case, there's 4 winning numbers here, and four numbers that match. The 48 matches, the 83 matches, the 86 matches, and the 17, but there's no 41. So there's 4 winning numbers. So in that case, you get 8 points, 1 for the first match, then you double, so it's basically, if you want to think of it, 2 to the n minus 1 power of values is kind of what you get for a line-by-line basis. So because there's 4 winning numbers, it's 2 cubed. And in this case, because there's 2 winning numbers, it's 2 to the first power, 2 to the first power, 2 to the 0th power, which is 1. And this is worth no points. Basically, that's where the formula breaks down because you can't have a negative power. That kind of works for us. And so in this case, when you go line by line by line and you sum everything up, you would see that 8 plus 2 plus 2 plus 1 gets me to 13. And so let's take a look at the code that will get us to the right answer for the larger data set. And so here is part 1. You can see my solution down below here. But basically, I'm going on a line-by-line basis. I don't need to worry about what game number or anything like that. I don't care about any of that, so I'm going to get rid of it. I'm going to split off that from the I'm going to split off from the colon, get everything to the right of it, and then split everything by the pipe. And then once I have that, then I can say, well, let's take everything to the left, list comprehension it, and these are the winning numbers, and everything to the right of the thing, that's the 1, that's where I'm going to list comprehension this thing and get everything to the right. Those are my numbers. And then now that I have that for the specific game, I'm going to go ahead here and start from 0.5 just so I can multiply things by 2. There's a couple other ways you could do this, of course, but this is the way I did it just to kind of get a solution. And I go through every winner in this specific game, and I check to see, is the thing in my number list? And if it is, multiply it by 2. So 0.5 becomes 1, and 1 becomes 2, powers of 2, 2, 4, 8, 16, and so forth and so on. And when I go through all of that, at the end of the day, if that total is greater than or equal to 1, or I guess you could even think of if it's greater than 0.5, it depends, it doesn't matter how you kind of write it out. That means that I found at least one thing, and then I will add that value to the list, or add that value to my sum total. And I just do this for every line in my data set. And like I said here, and like I will show you here in a second, you get 21,919 for part 1. And that is my solution there for part 1. Okay, so now for part 2, this is where things get a little more interesting. So let's talk about this in a little more controlled manner. So let's see if we can find an efficient way to describe the problem, and then we can describe how we solve the problem. So basically, instead of worrying about summing up totals like we did for part 1, for part 2, for the winning numbers that we get and the winning numbers that we match up with, we're going to be giving out more scratch cards for sequential games. And so just to say here, let's just kind of work through the problem here, and you'll see how this works out. Give me 1 second here to drag this down here so we can see the solution for the example. And in this case, 30 scratch cards is what we're going to get for this. But how we do this is, well, we're starting with 6 numbers here, 1 for each of the 6 scratch cards. And in this case, for card 1, as we described, there are 4 matching numbers. So basically, I'm going to add basically whatever this value is to each of the next 4 sequential cards. So I'm going to add 1 to here. This becomes a 2. This becomes a 2. This becomes a 2. This becomes a 2. And now card 1 is done. We don't have to worry about it anymore. We don't have to think about it. And now we're going to move on to card 2. And we say, well, we have 2 copies of that card, but then it says there's 2 matching numbers. And so in that case, we're going to be adding this value to 3 and 4. So we're going to add this, and this becomes a 4, and this becomes a 4. And then this is done. Not sun, it's going to be done. And so now moving on to the third card. The third card has, let's see, the 4 instances have 2 matching numbers. So we're going to add whatever this value is to here. and 2 here, and then 3 is done. And then we're going to do the same thing here. We have 8 copies of number 4, and since there's one matching number, we're going to add that to the next one here. So this becomes a 14, and that's done. And then for number 5 here, you can see number 5, there are no matching numbers, and you can't win any more cards. And so then that is done. And then because, basically when you get to the end here, there's nothing, you don't wrap around or anything. It would go on infinitely, right? So then when you get to the end here, there's no reason to kind of work it, but it doesn't really much matter. And you can see that the answer matches up with the 30 that you see here. And so it's just a matter of sequentially going through and figuring out what the count is at that current moment, and then adding that to the sequential cards based on the number of numbers that match up with the winning numbers. So with that understanding, let's now take a look at the code that does exactly that. How is it different from part 1? Okay, so here is the code I have for part 2. So things are a little different here. I generated the games and all the boards. I generated the data structure up front rather than generating them on a case-by-case basis. So I guess coming back to here, as you can see here, I didn't even maintain any information. I just processed each line on an individual basis. But coming to here, I need to maintain all of this because I need to go through all the games sequentially from front to back. So here, this is a little bit different. So now I have a data structure. Let me just show you real quick how that all works out here. Here, the games, you can see, oh my goodness, look at all this crazy stuff here, that all the winning numbers are the first element of the list. It's a list of lists. And then the second element is a list of my numbers. And then the third number here is a 1. The third element in my case is going to be how many cards are there of that specific game in play. So of course, when I start out, every one of them is, as I process the file one by one, there's only going to be one copy of that card. But as I go through the rest of the game here and I play each card and I add and I add and I add, these numbers are going to be changed greatly over the course of the enumeration here. So now what do I do here? Do I need this number? I do need this number because I'm generating, because I need to figure out when I go to add to all the sequential ones, I do need to know what the ID number or the index of the specific game is so that I can go ahead and add them to the sequential ones. So I do need to use the enumerate here to figure this out once I have the games listed. But just like before, I'm trying to figure out how many games or how many numbers for a specific game match up. And so that is basically the same, this is kind of the same as before. So I'm figuring, okay, how many numbers are there? And if there is at least one, so you could say if it's greater than 0 or if it's greater than or equal to 1, however you think of it, then I'm going to sequentially go and add the number of games, the number of cards that I have for that specific game to the next n ones that are the next total ones that I found. And so the only tricky part here was to make sure you don't go over the bounds of the list itself, so that this is why this is here to make sure that I don't go past everything that I'm supposed to, because if I go past, it's going to crash on me, and of course I'm not going to get an answer if the program crashes on me. So in this case, I say if there's at least one winner, let's add to the next n number of cards, the number of games, that number of scratch cards I have. Well, that many times I'm going to add that to the specific game that's in the list here. And again, the 2 plays up here because this is element 0, this is element 1, and this is element 2 of each individual game. So basically, figure out how many numbers there are, use the 0 and 1 element to figure that out, and then tinker with the second element to say I need to move this many scratch cards or I need to add this many scratch cards to the sequential numbers. And so that is the big difference here between part 1 and part 2. And then once I've generated all those values and I've kind of gone through and I've worked all of them over and I've gotten to the ends and I don't worry about, I haven't gone over the bounds of my number of games that I have, then I go through one more time here and sum up all the values, and then I print that out. In this case, you get the 9881048 as you see there. Oops, let me just to prove it here. It only takes a couple, just to run here. It just takes a little bit of time to make that work. I don't know how much time it would take if you basically ran the. It would take 9 million. You would be running 9 million of these things if you're running each game individually instead of grouping them together to figure out how to. That's probably the brute force part of this. I'm not sure how long it would take to do this on a case by case basis. It would work. It just would take a long time, or much longer than the 1 second or so that this does take in the way this is done here. So as always, if you know a better way, a couple of you guys have commented and thought of this and told me about your thoughts already. I would love to know if there's a more efficient way to do this. This is definitely a solution and it gets it done in a pretty quick manner. But this was a fun problem. For me, this was much easier than day three. Day three kicked my butt. I was up till 1 in the morning yesterday figuring it out. But that's my problem, not yours. And so looking forward to day five tomorrow, or day four tomorrow, or day four, day five, day four tomorrow, day five, whatever. It's already day four. And so day five, looking forward to that. I'm just gonna keep saying day four, day five, day four, day five. And I'm looking forward to seeing you guys in future videos. Thanks for watching. Take care. Have a good one. See you then.